Okay, so now I've shown you how to separate the variables. It's an opportunity for you to have a go at one. So here's an equation: dy by dx equals 3 plus 2y all over 4 minus 3x. And what you want to do for yourself is just pause, have a go at it, and I'll put up a solution as soon as you've done. Okay, so we've got dy by dx equals 3 plus 2y all over 4 minus 3x. First thing we're going to need to do is divide both sides by 3 plus 2y, because what we want to do is get that term over on the left hand side of this equation. So by doing that we get 1 over 3 plus 2y dy by dx equals 1 over 4 minus 3x. Now you've got the x's on the right, the y's on the left, and we're ready to integrate. We're going to integrate both parts of this with respect to x initially. So there we go. And it's very important that you do both sides obviously the same, because it's an equation essentially. We need to integrate the left and the right with respect to the same variable. So in this case, both sides with respect to x. However, in the same way as with implicit differentiation, we gave it a little respect. This time we're going to have to take it away. So we're now going to integrate 1 over 3 plus 2y with respect to y. And that's going to be equal to the integral of 1 over 4 minus 3x with respect to x. These are pretty straightforward integrals. You end up with a half ln 3 plus 2y equals minus a third ln 4 minus 3x plus your constant c. And that's it. You don't need to rewrite it. You don't need to put it in terms of y equals. That is essentially your solution to this equation. Okay, we're going to do another one that requires you to do slightly more work with regards to the separation of variables part of things. So here's another one. And obviously remember which side you need each of the variables on. Look at my examples if you need to refresh your memory, and hit pause and have a go at this question. Okay, so here we go. This time we've got the x's on the left and the y term on the right, and we need to swap them over. So by dividing by 5x and also dividing by 6e to the y, and I'm going to do those both steps together just to try and be slightly more efficient, we get 1 over 6e to the y dy by dx equals 1 over 5x. And don't forget that 1 over 6 e to the y is the same as a sixth e to the minus y. And that's quite useful when you're trying to integrate, to just put it in that form. And we're going to go off and integrate. I'm not going to show the dx part. I'm simply going to integrate now with respect to y. It should be quite obvious why we're doing that, and if not, just have a look back over the clips. So on the left we're now integrating with respect to y, and on the right with respect to x, and that's because we managed to get rid of this dx term at the bottom. That leaves you, and so that leaves you on the left hand side with minus 1/6 e to the minus y equals 1/5 ln x plus your constant c. Now because this is a fairly straightforward equation where you've got this e to the minus y term, which you could bring down to be an e to the y term, you could very well be expected to present this in the form y equals, and you might want to practice some of that manipulation yourself just to make sure you can do it. I got y equals ln minus 5 all over 6 ln x plus k, where k is a different constant to c, and that's allowed to change the constant just to make the constant slightly more simple later on. You might want to just practice that. Okay, that's it for differential equations, and that's it for this bunch of lessons. I'll send you a homework sheet that you need to complete by Tuesday that will go over all of these. Obviously look through the examples if you're struggling, and hopefully come Tuesday we shouldn't take too much time, just to recap and move on. Alright gents, well done and good luck.